Hello everyone, myself P. Suresh, Assistant Professor, Department of Electronics and Communication Engineering at Sri Venkateshwara High Tech Engineering College, Gopichettipalayam. In this video, we are going to discuss about solar energy and its applications. So let's get into the topic without any delays. So what is solar energy? The solar energy originates with the thermonuclear fusion reactions occurring in the sun. Represents the entire electromagnetic radiations like visible light, infrared rays, ultraviolet rays, X-rays, and radio waves. These energy consist of radiant light and heat energy from the sun. Out of all energy emitted by sun, only a small fraction of energy is absorbed by the earth. Just this tiny fraction of the sun's energy is enough to meet all our power needs. So, when we talk about solar energy, there are two kinds of solar energy, namely thermal energy and electrical energy. Talking about electric energy, the power of the sun is used to produce electricity with the help of solar cells. It can be used through a solar home system that helps in conducting electricity where there is no power supply. Apart from that, it can be used as a system where the electricity supply utility is connected to the property, and lastly it can be used as a backup system where there are frequent load shedding problems. So what is insolation? Insolation is the amount of solar radiation reaching the earth, also called as incident solar radiation. This value is generally expressed in kilowatt per meter square per day. This is the amount of solar energy that strikes a square meter of the Earth's surface in a single day. This value is averaged to account for differences in the day's length. It depends upon below listed parameters: atmospheric clarity, hour angle, seasonal variations and geographic locations of the particular surface, degree of latitude of the location, area of exposed surface, angle of tilt of solar panel, shadow of trees, tall structures, adjacent solar panels. So based on the angle of incident of sunlight, the components of solar radiance are classified into three types. Those are direct radiation, diffuse radiation, reflect radiation. So direct radiation means the direction of the sun coming on the Earth's surface without any change are called direct radiation. Diffusion radiation. The radiation of the sun received by the earth after the change in the direction by reflecting and scattering effect by the atmosphere, such as radiations, are known as the diffuse radiation. Total radiation. It is a sum of beam radiation and the diffuse radiation. Such radiations are called as total radiation. Total radiations are given by diffusion radiation plus beam radiation. So as I already said that out of all energy emitted by sun, only a small fraction of energy is absorbed by the earth. So in this picture we can clearly see that the 100% of sunlight is coming from sun and only 70% is absorbed and 24% directly used. Remaining around 30 or 40% of the sunlight is scattered or remains unused. So using present solar technique, some of the solar energy reaching the earth utilized for generation heat and electricity. Even though the utilization of solar energy is increasing day by day, still it is not utilized at its full potential. Only 0.8% of energy is utilized from the solar energy resources. So why solar energy? The fossil fuels are not renewable sources. We cannot depend on them forever. Though nuclear energy is a clean and green energy, as said by Dr. APJ Abdul Kalam, there are always some problems associated with it. So the only option we have is solar energy because it is a non-polluting and a silent source of electricity and also low maintenance and a long-lasting energy. How solar energy is used? The solar energy is used in the form of solar thermal energy, solar heating, solar electricity generation using solar concentrators and photovoltaic cells. So what is solar thermal energy? Solar thermal technologies involves harvesting energy from the sun for heating water or producing electrical power. Solar collectors are used for these purposes. So let's discuss about solar collectors. Solar collectors are used to collect the solar energy and convert the incident radiations into the thermal energy by absorbing them. This heat is extracted by flowing fluid in the tube of the collector for further utilization in different applications. Here we are going to discuss about three types of collectors. Those are flat plate collectors, evacuated tube collectors, integral collector or storage systems. The first one is flat plate collectors. The flat plate solar collectors are probably the most fundamental and most studied technology for solar powered domestic hot water system. The basic principle for this device is that the sun heats a dark flat surface which collects as much as energy as possible, and then the energy is transferred to water, air or other fluid for further use. Let's see the construction and working of flat plate collector. From this diagram we can see that the components of flat plate collectors are solar glasses, absorber, insulation, tubing, housing and water outlet. The absorber plate is used to absorb the incident solar energy. It is basically a copper or aluminum sheet coated with selective coating. Next, solar glass. It is a transparent layer that transmits radiation to the absorber but prevents radiative and convective heat loss from the surface. The next one is tubes. The tube contains heating fluid to transfer the heat from the collector. And finally, the insulation and housing. It is a polymeric material that protects the components and holds them in places. Covers the sides and bottom of the collector to reduce heat losses. The schematic of a flat plate solar collector with a liquid transparent medium is given here. The black absorber plate absorbs radiant heat from sunlight. The black absorber plate is covered by transparent screens to reduce the heat loss. There are tubes carrying water which gets heated due to the heat absorbed. The thermal insulations prevents heat loss during the heat transfer. The flat plate system normally operate and reach the maximum efficiency within the temperature range from 30 degrees Celsius to 80 degrees Celsius. However, some new types of collectors that employ vacuum insulation can achieve higher temperature up to 100 degrees Celsius. Due to introduction of selective coating, stagnant fluid temperature in flat plate collectors has been shown to reach 200 degrees Celsius. Flat plate collectors need to face the sun to obtain maximum sunlight exposure. The insulation angle should be equal to or up to 50 degree higher than the latitude of the location. This angle ensures optimal heat output through the year. The flat plate solar collectors are highly useful for low temperature heating. The main use of this technology is in residential buildings where the demand for hot water has large impact on energy bills. Commercial applications include car washes, military laundries, and eating establishment. Some advantages of flat plate collectors are it is easy to manufacture, it has low cost, it can collect both beam and diffuse radiation, permanently fixed, and it requires little maintenance. The flat plate collectors also has some disadvantages. Those are the initial cost of installation is high, heavy in weight, low temperature is achieved, large heat loss by conducting due to large area. The next solar collector we are going to see is evacuated tube collector. The evacuated tube collectors consist of a number of rows of parallel transparent glass tubes connected to a header pipe and which are used in places of the blanketed heat absorbing plate. These glass tubes are cylindrical in shape, therefore, the angle of the sunlight is always perpendicular to the heat absorbing tubes, which enables these collectors to perform well even when the sunlight is low, such as when it is early in the morning or late in the afternoon, or when shaded by clouds. Evacuated tube collectors are particularly useful in areas with cold, cloudy wintry weathers. This image shows the schematic of evacuated tube collectors. Inside each glass tube, a flat or curved aluminum or copper finish attached to a metal heat pipe running through the inner tube. This fin is covered with a selective coating that transfers heat to the fluid that is circulating through the pipe. These copper pipes are all connected to a common manifold, which is then connected to a storage tank, thus heating the hot water during the day. The hot water can then be used at night or the next day due to the insulating properties of the tank. The advantages of evacuated tube collectors are it achieves high efficiency with large temperatures, differences between absorber and surroundings, supports space heating, achieve higher temperatures, low in weight. The disadvantages of evacuated tube collectors are it is more expensive to initiate a evacuated tube collector system and cannot be mounted horizontally, must have a slope of 25 degrees. The next topic we are going to discuss about is water heating. To heat the water using solar energy, there are two methods are available: passive solar heating systems and active solar heating systems. In active solar heating system, the system that uses water or air that the sun has heated and is then circulated by a fan or pump. But in passive solar heating system, the house itself acts as a solar collector and a storage facility. No pumps or fans are used. The system makes the use of material for the house to store and absorb heat. The next topic is space cooling. The heat from a solar collector can also be used to cool a building by using the solar heat as an energy source. In space cooling, evacuated tube solar collectors and solar panels absorb the sun's heat, which is then used to heat up a 1200 gallon insulated hot water storage tank until the water reaches 180 degree Fahrenheit. The hot water is then pumped into a generator, then into a chiller. The chiller contains an absorbent, usually lithium bromide salt. This absorbent yields the refrigerant which condenses and produces chilled water. The air from inside the building is pushed by a fan over the coil units containing the chilled water. Then now cool air is circulated back into the building. There are single effect and double effect absorption systems. Double effect systems uses the heat twice in the series and are twice as efficient but require nearly twice as much heat. The next topic is electricity from solar energy. Solar power is described as the conversion of sunlight into electricity. Sunlight could be changed into electricity with the use of photovoltaic cells or CSPs. CSP stands for concentrated solar power. CSP is a power generation technology that uses mirrors or lenses to concentrate the sun's rays and that heat a fluid and produce steam. The steam drives a turbine and generates power in the same way as conventional power plants. Solar power is concentrated in various ways. There are now several devices and structures created which focus and concentrates solar power. Solar parabolic throats, Stirling dish, solar power tower, the linear Fresnel reflector. These are all the devices that are structured and created for focusing on solar power. So, what is photovoltaic cells? Solar photovoltaic is a technology that converts sunlight into direct current electricity by using semiconductors. When the sun hits the semiconductor within the PV cell, which means photovoltaic cell, electrons are freed and forms an electric current. Solar photovoltaic technology is generally employed on panels. Photovoltaic cells are typically found connected to each other and are mounted on a frame called module. Multiple modules can be wired together to form an array, which can be scaled up or down to produce amount of power needed. Solar cells works on the principle of photoelectric effect. It is the conversion of sunlight energy into electricity in a PV system. The PV cells exercise this effect. Semiconducting materials in the PV cells are doped to form PN structure as an internal electric field. The p-type silicon has the tendency to give up electrons and acquire holes, while the n-type silicon accepts electrons. When sunlight hits the cell, the photons in the light excite some of the electrons in the semiconductors, become an electron-hole pair. Since there is an internal electric field, these pairs are induced to separate. As a consequence, the electrons move to the negative electrode while the holes move to the positive electrode. A connecting wire connects to the negative electrode. The load and the positive electron is in series to form a circuit. As a result, an electric current is generated to supply the external load. This is how PV effect works in a solar cell. So the next topic is the type of solar electric systems. First, the standalone system. Standalone or off-grid solar power systems consist of solar panels and battery bank. It is used in rural areas and regions where there is no access to the utility grid, and it is very good at giving economical electricity. A simple standalone PV system harnesses the solar energy and stores it in a battery that could be used even at night times when there is no sunlight. A standalone small scale PV system employs rechargeable batteries. On further, it is connected to the standalone inverter to convert direct current to alternating current, making it available to connect AC loads. The next topic is grid tie solar system. It is very useful for homes that are already linked to the utility grid. Primary advantage is the cheap price of utility. The system needs to be wired with an inverter that creates AC electricity, which is needed for linking to utility grid. In a grid tie solar system, electricity generating systems that is connected to the utility grid. A grid connected to PV systems consists of solar panels, one or more inverters, a power conditioning unit, and grid connection equipment. When conditions are right, the grid connected PV system supplies the excess power beyond consumption by the conducted load to the utility grid. Let's see the uses of solar energy. Solar energy is used in heaters, cars, lights, satellites, dryers, calculators, greenhouses, water pumps, desalination, chilling, solar ponds, and thermal power stations. And other commercial uses are it is used on office building, roof areas can be covered with solar panels, and remote buildings such as schools, communities, and in developing countries like these solar panels are very much useful. Even on the highways, for every 5 kilometers, solar telephones are used in some countries. Developing solar power in India. In India, about 70% of the population lives in some 50,000 villages dispersed around the country. Many of the villages are far from the main transmission lines of the national grid because of their relatively small populations. It is not economically viable to connect these villages to the grid. Solar energy has great potential in areas of India that receive high solar radiation throughout the year. For example, 90 megajoules of solar energy per square meter is received every day. The nationwide average is 5.5 kilowatt per meters per day. Enough energy potential for solar energy because there are 250 to 300 sunny days per year. Continuous cloudy days are rare. And next, advantages of solar power development in India. The power source of the sun is absolutely free. The production of solar energy produces no pollution. The technological advancements in solar energy systems have made them extremely cost effective. Most systems do not require any maintenance during their lifespan, which means you never have to put money into them. Solar energy systems are now designed for particular needs. For instance, you can convert your outdoor lighting to solar. The solar cells are directly on the lights and can be seen by anyone. At the same time, you eliminate all costs associated with running your outdoor lighting. Solar energy can be used in remote areas where it is too expensive to extend the electricity power grid. It is estimated that the world's oil reserves will last for 30 to 40 years only. On the other hand, solar energy is infinite forever. Solar energy can be used in remote areas where it is too expensive to extend the electricity power grid. Solar cells are long lasting source of energy which can be used almost anywhere. Solar cells are totally silent. And the disadvantages of solar power. Initial cost. The initial cost of the purchasing and installing solar panels always become the first disadvantage. Although subsidy programs, tax initiatives and rebate initiatives are given by government to promote the use of solar panels, we are still way behind in making full and efficient use of solar power energy. Locations. The location of solar panel is a major importance in the generation of electricity. Areas which remains mostly cloudy and foggy will produce electricity but at reduced rate and may require more panels to generate enough electricity homes. Houses which are covered by trees, landscapes or other buildings may not suitable enough to produce the solar power. Pollutions. Most of the photovoltaic panels are made up of silicons and other toxic metals like mercury, lead and cadmium. Pollutions in the environments can also degrade the quality of and efficiency of photovoltaic cells. New innovative technologies can overcome the worst of these effects. Reliability. Unlike other renewable resources, which can also be operated during night, solar panels provide to be useless during the night, which means you have to depend on the local utility grid to draw power in night. Inefficiency. Since not all the light from sun is absorbed by the solar panels, therefore most solar panels have a 40% efficiency rate, which means 60% of the sunlight gets wasted and is not harnessed. Installation areas. For some home users, a solar energy installation may not require huge space, but for big companies and a large area is required for the system to be efficient in providing source of electricity. The above, the above map shows the data of the utilization of solar energy in different states of India. Among that, Karnataka is the top number one state that uses solar energy, which produces 5 gigawatts of electricity. And these data are collected in around 2017 to 2018. The next topic is better ways of usage of solar energy. Government should take measures and see that solar lights are used as street lights in the areas. We can place solar panels in the barren lands instead of keeping it away uselessly. We can also keep the solar panels in the deserts where we can make use of this energy with the help of a rechargeable battery. Efficiency of solar panels depends on the range of frequency of light that strikes on the surface. So they can give higher frequency if we split the light into different frequency ranges and direct the beams onto the cells turned to these frequencies. Building a new home is the best time to design and orient the home to take advantage of the sun rays. And these are all the overall concepts of solar energy and its applications. Thank you for watching and make use of this video.